of sets. Now let us go ahead and understand the different types of set. The first type is known as a universal set. A universal set is basically consists of all possible values. Let me give you a universal set. Ideally, slowly I will call this as union, because again I will take all possible values. That is why it will be called union. That's why union is represented by a universal set symbol. Now please see this thing. So I'm taking all possible values, right? So suppose I have a set A. A consists of 3 and 4. I have a set B. B consists of 1, 2, 6 and 7. And now I'm asking what is the universal set? Then you will take all possible values, which means you will take 1, 2, 3, 4, 6 and 7. So you will take all values. Suppose if you had 5, let's say 6 coming here also, then you will take 6 only once, because you will do a unique representation. You will not take 6 twice. So if the same number appears twice, you will only go ahead and take that number once. Now let's go ahead to the next example. Empty set or null set. See, please understand that an empty set is represented by phi or brackets with nothing inside them. An empty set is not equal to 0. Empty set simply means that nothing is inside this set. Neither it is equal to a set with 0 inside it. All these three things are very different. So understand this first. Suppose I tell you that X is such that X belongs to natural numbers, and I tell you that I have X, let's say X between -1 to -half, suppose. Now, if I draw a number line, this is very simple. This is 0, this is -half, this is -1. It says X should be between -half to -1, which means it should be here. But it says that X should be a natural number, which means it should be here. I cannot satisfy both of these things together. So the final outcome of this is that this set would be a null set, or like this, right? This is the meaning of null set. Please understand. Now take another example. Suppose I tell you X is such that X is a whole number and X is between -1 to 0. Now, if I think about this, then in this example that I have taken, X is a whole number, which means it can be 0, 1, 2, or anything positive from 0. And this says that X is between -1 to 0. So if I take -1 here, according to this, X can be between -1 to 0. So what is the common point between these two? How do I say what is common between these two? Only X equal to 0. So, the answer is that I have a set with only one value 0 inside it. This is not equal to empty set, which was there earlier. This set has a value, but that value is 0. And the third is when it's not a set only. It's just a value 0, but it is not a set. So empty set is not equal to 0, is not equal to a set with 0 inside it. All three things are very different from each other. Now, singleton set. singleton set basically is any set which, if you go ahead and this number 3, just make it correct. Here we will have this as example of null set. This I was giving as an example of null set, and I will tell you how this appears as singleton also. But take this first of all as an example of null set. So x belongs to natural number, but x is between 3 and 4. So between 3 and 4, not including 3, not including 4, means that x is basically having nothing in between. So it becomes a null set, right? Now, when we talk about singleton set, a singleton set is anything that has exactly one element inside it. So it should have exactly one element. Like for example, this. It only consists of one. Like for example, this 1, 2, 3, 4, 5 without comma. So I will read this as 12,345. This is a singleton set. This is correct. But now take this example. 1, 2, 3, 4, 5. These are 5 elements. So this is not a singleton set. Now, this is a trivial question that I want to ask. That is a null set singleton set? And the answer to this is actually yes. A null set is also a singleton set because it consists of exactly, this is trivial, okay? It consists of exactly one element, and that element is actually null. So when I write like this, right, this is also a singleton set. When I write this, this is also a singleton set. When I write, in fact, this is also a singleton set. So this is a singleton set where the element of this set is a set in itself. So if I say A is equal to A, this means that A consists of only one element. And what is that element? That element in itself is this, which is a set. So element of the set is one set, but it is a singleton set. Okay. So a singleton set is anything which consists of exactly one element. Now let's understand what is a finite set. A finite set is whenever you have countable elements. When you can count on something. So here I can count that there are 5 elements. So it is a finite set. So whenever you can count the number of elements, it is a finite set. Now, a lot of times, again, a tricky question, is the set of natural numbers a finite set? The answer is yes. I can still count it, right? You pick up any number, I will be able to give it some position inside the set. So it is in fact a countable set. So yes, the set of natural numbers, the set of integers, these are all finite sets. Now, what is an infinite set? The moment I go ahead and I put these dots and I cannot give the number, what is, I cannot count any particular number, then it becomes an infinite set. So for example, let's say I have a plane. Right? And I ask you that I create a set S, and I say that this set is the set of all points on the plane. Well, I cannot count how many points will be there. Many points, infinite points. Then this is an infinite set. Similarly, if I tell you my set consists of lines that can be drawn on the plane, you can draw infinite lines on the plane, so that I can draw as many lines as I want. Anything that touches my plane at any point of time. So because I can draw infinite lines on my plane, I cannot count how many. It is an infinite set. So any set which cannot be counted on numbers, anything which has no limit to it, for example, the number of points on the plane, the number of tangent lines that you can draw on the plane, etc. These are all infinite set. Now, the next is called a subset. A subset is basically some part of a bigger set. So I'll talk about this in some while, but for now you just have to understand a subset is some part of one big set. So for example, when I say that I have a set 1, 2, 3, 4, 5, 6, and I create some part of this set. I pick the first 3 elements of this set, then A is a subset of S. But I'll talk more about this a little later. So for now, you just have to understand some part of the set. When that is created, it is called a subset.